All right, ladies and gentlemen, welcome to the Technical Deep Dive. Your host here, Eric Kavanaugh of the Bloor Group. I'm so excited to have Sean Knapp with us of Ascend to dive into one of the most interesting concepts I've come across in a while now, intelligent persistence. We're going to touch on various things, but this concept I think is fascinating. This whole technology is blowing my mind, I'm not going to lie. But with that, Sean Knapp, what is intelligent persistence? How does it work, and why is it valuable?
Thanks for having me, Eric. When we think about the notion of intelligent persistence, probably sounds really fascinating and probably a bit foreign to a lot of folks. But the reality is we've been doing really similar things in other domains of technology for quite some time. Web applications for the longest time have done caching, whether it's at the page level or fragment level or even at the data level. We see the same thing with databases. They do a lot of really intelligent caching of data to really just tune and optimize speed and better manage resources. When we think about the notion of data pipelines, pipelines don't pull data from one system to another, but instead push data from one system to another. And what we've done in this notion of intelligent persistence is simply apply similar principles around how do we not repeat work. Mm-hmm. And so as we look at, for example, the Ascend product here, you'll see this is the canvas. We follow a similar sort of notion of we're extracting some data here, putting it through cascading transforms, and eventually loading it up somewhere else. Oftentimes it's out of S3, doing SQL and PySpark transforms, and then putting it back into S3 or a warehouse. And we're not going to spend too much time on that. But when we think about this notion of intelligent persistence, most pipelines to date don't persist at any of the transform stages, certainly not long-term. They'll instead only persist at the extract and the load categories. What we have figured out how to do at Ascend, however, is how to persist data at every stage. And so what you'll see is as I click on the records here and load up records, what we're doing is we're actually loading records directly off of, in this case, S3, the local blob store. And I can do this for any component at any stage of any set of these transforms. And the reason that we can do this and browse these records just as if they were individual database tables is because we're persisting that data. Mm-hmm. And this gives us a lot of really interesting things to start to do because it's no longer the data just as it's flying through a transform on a pipeline that's run on some sort of a cadence, but instead, it's actual concrete data that is sitting in that blob store that we can start to do really interesting things with. So, for example, I can not only browse the records inside of these various components, but I can also do things like query them. So I can come in here and start to treat that transform, what used to be entirely ephemeral storage and data that's just flying by. I can come in here and I can actually run queries against that. Wow. And those queries actually operate as if it were a database or a data warehouse in this particular case. I can also do really interesting things like look up the results of previous queries because the system itself knows how to persist. I don't have to rerun the data. I can just simply let it refresh. Mm-hmm. And you'll see here that query from that warehouse didn't have to touch any of the original data. It just simply goes to the most recent data. If I go back over here to my graph, you'll also see that a bunch of different data sets are running here and here at times, but I won't necessarily have to run and I'm not having to process data all the way up here because that data was already processed before. And so even though I have hundreds and hundreds of partitions of data that are floating through here, you'll see very little new work actually being done at the same time. Because an intelligent enough system, just as an intelligent caching system, an intelligent persistence system for pipelines also knows that the work is already done.
Yeah. This is reminding me a little bit of when Ajax came out. Remember when Ajax came out? That's got to be 10, 12 years ago now. Asynchronous Java. Basically, it's somewhat similar in terms of its functionality and how it empowers the users to get some specific thing done without having to reprocess a long pipeline, right?
Yeah, exactly. We've seen a lot of these technologies pop up over the course of time, really to try and help provide a few of these benefits. One is obviously performance, and how do we make sure that we're not repeating work that's already been done before. The other is, really around flexibility. If you can simplify that programming model and you can figure out how to access intermediate data, you can start to branch on top of that data far easier than you ever could before. And you no longer have to go all the way back upstream and read the data back off of S3 or out of a database or somewhere else, but instead can tap into the properly refined data sets that are just simply further down the stream.
Yeah, well, you're enabling a much deeper level of discovery, both for troubleshooting and just for analysis, right? So the analyst can jump in at any point along this pipeline and review data sets in their stage of refinement, for example, and find the optimal place to launch off their new idea. And this all gets back to what we talk about all the time, a conversation with data. If you have a nice, fluid flow of ideas and data and an ability to view what's happening in here, that facilitates the analysis process that really empowers the analyst to get to their answers quickly and to build upon a solid foundation that also, by the way, has all this sort of safety and other stuff baked into it, right?
Yeah, exactly. I think the sort of classic paradigm for building of data systems, both on the data engineering and the data science side, has historically been a incredibly high latency from a development perspective process, because you'll see going from the exploratory mode of you have an existing data set, it's part of a refined pipeline and it's working, and now you're exploring it and you find some new data set that should be part of the standard refinement process, and that gets shipped back to the data engineering team to go build and implement. And you end up with this really slow back and forth process, as opposed to, frankly, a far more fluid and agile development process when it comes to data. And I think the thing that you highlight that's really important about this is you need really those three core things that intelligent persistence provides you, which is this combination of performance gains, which of course you get from the intelligent persistence, but also you need the ability to provide flexibility where you can tap into any stage of any data pipeline, which we've talked about. And then the last thing you touch on, which was safety. Like, you really do need to make sure that you can do so safely. This notion of intelligence persistence, you have to be able to guarantee that the right piece of data is actually there. It's in sync with the code that's operating on it. Because if you can't do that, it's the same thing of having a caching system that could potentially corrupt your data. And so you need to have a system that's smart enough to guarantee that the right data is sitting underneath the right transform.
Wow. Yeah, I've got a history in the oil and gas business, and I remember studying how raw oil gets purified and gets created into, or gets basically refined into different kinds of products. And what this reminds me of is you're kind of giving the end user the ability to dig into a pipeline. That's something that used to require shutting down the whole operation and then bringing in the workers. Now you can actually go in and work on something that is in the active pipeline right now without disrupting everything else around it, which is a really, really big deal. Like, because before you had this tremendous opportunity cost, knowing that if you're going to try to fix something, you got to shut everything down, to get the lockdown in place, basically. But now you don't have to do that, so you can essentially change the tire while the car is running, right?
Yes, actually, and I really love that analogy around not having to shut down the entire oil pipeline to simply tap into and explore parts of that pipeline, and that's 100% correct. Where historically, if I wanted to start to explore and touch on this system and tap into that data, or even edit and prototype a change to this stage of the pipeline, I would have to shut down the entire production pipeline to grab those resources and grab that data and start to modify it, which becomes rather untenable for most companies. And
that's right.
In this world of intelligent persistence, you simply don't have to. You can actually run all exploratory efforts side by side with your production efforts with mathematical guarantees that the right data is ending up at the right spot.
Oh, wow. You've got a line that you use often where you say you never run code on the same piece of data twice. Can you explain that quickly?
Yeah, well, I can explain it. Whether or not it's quick, let's give it a shot. So the idea behind this is, the classic way of building data pipelines is you write a bunch of code, you put it into GitHub, and you have some automated system that's pulling that code out of GitHub and running a job, right? It's every hour it's doing this thing on your data. It's pulling data from somewhere, transforming it, and writing it back down. And that system that schedules all of this, all it really knows about your code is that it did something at some time interval. It doesn't actually understand your code. And as a result, it doesn't know if the changes you made to your code may have actually produced a different piece of data than what it did before. The approach Ascend has taken to this is we actually, at every stage of every transform, understand the code that's operating on your data. And the core idea behind this, and it really boils down to that simple sort of notion, is we understand the code well enough to know that whether or not it would generate new data. And if you fundamentally change the code, we are then regenerating the data, the output data. We're rereading in that input data and regenerating the output data because we know the data the previously processed data no longer matches the code that you have submitted, whether it's into your Git repo or directly into the application. And so this is the core of it is based on a pretty advanced SHA-ing convention of doing secure hashes on the code and the data itself, that we know with mathematical certainty, we can guarantee that the right data is always underpinning each one of your transforms based on the same security model that we use in cryptography and across the internet. And so for us, this has been that huge innovation to always guarantee the right data ends up at the right spot.
I love it. Well, folks, this has been a technical deep dive with Sean Knapp of Ascend. Look them up online, ascend.io. This is the first of a series of technical deep dives. We'll talk to you next time, folks. Take care. Bye-bye. Oh, and one more thing. So, Sean, we talked about performance, flexibility, and safety, but we want to talk a bit about access to the files itself and more flexibility. So talk about that middle point real quick.
Yeah, it's interesting because inside of the Ascend platform itself, obviously, we give you this really pretty interface to actually navigate and access a lot of your data. And there's all sorts of great APIs and so on for doing so. But there's a whole host of other tools outside that speak different protocols, and oftentimes are looking for not a streaming API of records or something along those lines, but are looking to tap into things that look probably something a lot similar to S3 or Google Cloud Storage. So one of the things that we've also added is this ability to tap into your data directly into the layer that's sitting inside of the blob store. And this is whether you're trying to list out those components or actually go all the way into the data itself. You can tap into those very specific Parquet files that underpin each and every single component.
Wow.
Now, one of the really cool parts about this is you can take it into your notebooks. You can stream this into your other Spark clusters or your Hadoop and Hive jobs. But part of this really cool thing tied to the notion of intelligent persistence is you end up introducing this layer that sits on top that's a bit of a safety system for how you're accessing the data. Traditionally, when you're reading all of your blob data out of your blob store, you don't really get any guarantees around is that data being changed while you're trying to read it.
Interesting.
One of the things that we were able to add in this intelligent persistence layer is the safeguard that says at the point in time you're reading it, everything you listed out of S3 and everything you're reading is always guaranteed to be committed, safe, valid data that was tied to that pipeline at the point in time you were trying to read it. And so you get all of the safety associated with never reading data that might be accidentally changing out from underneath you while you're trying to read it. Wow. This is something that most other storage systems themselves can't provide, but with an intelligence layer that sits on top, you now get all these added benefits.
Wow. That is very, very cool stuff.
Yeah.
Excellent material for a technical deep dive. Well done.
Awesome. Thank you so much. And the last thing I'll highlight for folks is if you're interested in trying out the intelligence persistence layer and all of the other really great stuff that sits around it, go to our website. We have free trials, and you're welcome to go kick the tires and give it a go.
All right, folks. Talk to you next time. This has been your host, Eric Cavanaugh, with Sean Knapp of Ascend on a technical deep dive. Talk to you next time. Bye-bye.